which is rhombi and squares. Now, rhombi is the plural form of rhombus, right? So we're talking about a rhombus and a square here. Okay. Again, they have their own properties that we can apply to each of these figures. They're pretty straightforward as well. Okay. So some definitions you'll need to know are these two. Okay. What a rhombus is it's a quadrilateral where all four sides are congruent. One of the examples is a square. It doesn't have to be a square, but a rhombus has all four sides congruent, and a square is a quadrilateral that's both a rectangle and a rhombus. So it's a rhombus in that it has four sides congruent. It's a rectangle in that it has all four right angles. Okay. So, again, these are on your postulate sheets here under 6.5. Okay? You know the diagonals of a rhombus are perpendicular. Okay? So if I tell you something is a rhombus, where the diagonals meet make four right angles. Okay? So if they are perpendicular, then it's a rhombus. It's just the converse of this theorem. Here I said if you have a rhombus, the diagonals are perpendicular. Here I say if the diagonals are perpendicular, then you have a rhombus. Okay? In 6.17, each diagonal of a rhombus bisects a pair of opposite angles. So if I tell you this figure is a rhombus, each diagonal bisects these angles. Bisects angle D, bisects angle B, C, and A. Okay. So rhombus has several different properties that you can apply here. Okay. Bisects these angles and makes four right angles where they intersect. Okay. Again, those are on your postulate sheet, so you don't have to memorize those. So, for example here, if I told you this figure is a rhombus, find the value of y. If I tell you that angle 1, so this might be a good one to have, is y squared minus 54. So since it's a rhombus, you know those four sides are the same. Okay. And also, since it's a rhombus, you know each of these angles are bisected. I don't necessarily need that in this problem. But. And then it says find angle 1 if it's y squared minus 54. So again, one of the theorems of a rhombus is that where the diagonals meet, they make four right angles. So that means y squared minus 54 has to be equal to 90 degrees. Right? Yeah. Add 54 to both sides. I get y squared is equal to 144. So then to solve for y, to undo that squared, I take the opposite of squaring something, which is square root. And I get y is equal to, I'm only going to write the positive answer 12. It could also equal negative 12, but you don't care about the, or it could also equal negative 12 in this case actually, because once you plug it in for y, it's going to be 90. Right? When you take the square root of both sides, remember you usually have to write the plus minus out in front, which means positive and negative. So in this case, it could equal 12 or negative 12. The reason it could equal negative is because this is just a variable. If it was a side length, it couldn't equal negative. But it's a variable, so y could equal 12 or negative 12. Once you square it, it becomes positive. Subtract 54, it becomes 90. MLP is 64 degrees. I want to know what is P and L, this angle. Okay.
64 divided by 10.
Right. One of the properties of a rhombus is that each of the diagonals bisect these angles. So that means these are both 32. We also know opposite angles of a rhombus are congruent. So this is 32, which means that is 32. Okay. You could also, if we wanted to, we could find what angle NPL and NML are, right? We know since that's a rhombus, that's 90 degrees. We know that's 32 degrees, and it makes a triangle with this one, right? 90 and 32 is 122. So that means left over to make 180 degrees here would be 58 degrees, right? So each of these angles would be 58 degrees. Same with these. So just by knowing that one angle, and that's a rhombus, I can figure out each of those angles. Okay. Just applying those theorems.
Wait, did you divide one?
I subtracted that from 180 because I have that orange triangle there.
Yeah, I was gonna say.
To get 58. Yes, question. Figure, and I went ahead and graphed it. Determine if this is a rhombus or not. Okay. So, what's the definition of a rhombus again? What's the definition of rhombus? Yes.
A quadrilateral.
By looking at this, it looks like it could be a rhombus. I don't know for sure. So in order to check, I want to check if all four sides are congruent, which means I need to find the distance of all four of these sides. So I would use the distance formula. And I would apply that to each side of this figure. I'd want to check between each of these what the length is. So I would use these 2 points to find FG, these 2 points to find GH. I would plug all of those into the distance formula. Okay? In this case. So for example, to find FG, take the second x minus the first. Simplify that. We won't do all of these, but let's look at this one. The distance of FG would be square root of 13, right? So I would find that's the square root of 13, and then I would check what is the distance of GH. Okay. I would take the second x coordinate minus the first, plus the second y coordinate minus the first. It would also be square root of 13. So this is square root of 13. And then I would check the other two to see if they are the square root of 13. If they are all the same, okay. Again, this is a 1 here. I kind of messed that up. This is a 1. If they're all the same, then it's a rhombus. In that case, if we went back to it to find it's a rectangle, we would test if all angles were 90 degrees. Okay. Now, is a rectangle also a square, or is a square also a rectangle? A square is also a rectangle, right? A rectangle is not a square because why? Not all the sides are congruent, right? Correct. Okay. So, again, rhombi, they have all the properties of parallelogram. In addition to all sides are congruent, diagonals are perpendicular, and diagonals bisect the angles. Squares also have all the properties of parallelogram. In addition to square, in addition to rhombus.